This video is on classwork for Integrated 3, Chapter 3, 24, 25, 29, and 30. Okay. So this first one, so all these are solving systems. Some of them are solving them algebraically, some of them are solving it graphically. So this one's going to solve it algebraically. And this one is actually not even a system. It's just an equation where we have the square root of 2x plus 3 equal x. But on the next problem, we're going to see how to solve it as if it was a system of equations, and we're going to do it graphically. So when you have a square root, your goal is to get your square root isolated and then look on the other side and see what sign this is. Because this is a principal root, this needs to be not negative, okay? So either 0 or a positive. Right now we don't know what it is, so once we get our answers, we need to plug them here and see if it's going to give us a positive or 0, then it's a good answer, or if it ends up giving us a negative here, then it's going to be no solution for that. So let me just rewrite this. Square root of 2x plus 3 equals x. We're going to square both sides. So I'm going to square this side. I'm going to square this side. When I square this side, I get 2x plus 3. When I square the other side, I get x squared. Anytime you have x squared along with an x, you definitely want to get everything on one side, 0 on the other side. I always want to make sure that my x squared is positive, so I'm going to bring everything over here with the x squared. So I'm going to have 0 equals x squared minus 2x minus 3. Now I'm going to factor this. There's no number in front, so I can actually think of this as a diamond. What multiplies to negative 3 and adds to negative 2? So that's going to be a negative 3 and a 1. So that is going to give me x minus 3 and x plus 1. And then I'm going to solve each of these factors. So this is going to be x equal 3, and this one here is going to be x equal negative 1. Now remember, we need to come up here and we need to check to see if this right here, that x is positive or negative. So when I put 3 in here, that's going to give me a positive. So this one is actually going to be a solution. But when I put negative 1 in here, that one's going to give me a negative. So that one is not going to be a solution. So this one's not a solution. This one will be a solution. And here, let me cross that out in a different color so we can see what we had there. Okay, so this is not a solution, and this one is a solution. Okay, so now we're going to see the same problem, but we're going to look at it in a different way. Okay, so here it says, when a result from a correctly solved equation does not make the original equation true, it's called an extraneous solution. This negative 1 up here was an extraneous solution. It is not a solution of the equation, even though it is the result when solving algebraically. Did question number 24 have any extraneous roots explained? So, yes, x equal negative 1 was extraneous. And why was it extraneous? It was extraneous because a square root, a principal root, has to be positive, and that ended up making it negative. Okay. Okay, next one. It's the same problem as what we just did at the top, but this time we're going to be looking at it graphically. So here on 29, it says, in math, we sometimes use a graphing method to solve equations, especially when we don't know any algebraic methods to solve the problem. Now, the last one, we do know how to algebraically solve it, but we're just using this as a introduction to this. So we take the equation and make it into two equations. So for example, in equation 24, we would change the square root of 2x plus 3 equals x into two equations. One of them is going to be y equal this side, okay, y equal 2x plus 3, and the other one's going to be y equal this side, y equal x. And then we're going to graph both of these on the same set of axes and see where they intersect, okay? So let's come over to this graph. And the first one I'm going to graph is y equal x. Let me just write it here. Y equal x. That's what I'm graphing right now. So y equal x is really a line. The y-intercept is 0. The slope is 1, so I'm going to go up 1 over 1, up 1 over 1, and so forth. Okay. You want to be accurate when you're solving a system because you don't want to be guesstimating. You want to be exact. Okay, so now I'm going to connect this. Okay, so I connected those points. So then the next one I'm going to graph. Okay, I'm going to graph that in a different color. It's going to be the square root of 2x plus 3. Okay, so y equals square root of 2x plus 3. That's the other side of that equation. And what I'm going to do is I'm going to figure out what makes this 0 underneath. And so I would take 2x plus 3 equals 0 and work it out. So I'm going to be subtracting 3 and dividing by 2. So I'm going to end up getting x is equal to negative 3 over 2 or negative 1.5. So I'm going to come over here and I'm going to go to negative 1.5, okay, on my x, and comma 0. So it's going to go right here. Then what I'm going to do is this one is not just a plain old square root of x plus or minus something. We've got this number in front. So let's just try to think of numbers that will be nice perfect squares, okay? So if I put in a, let's see, a 0, that is not going to be nice. If I put in a negative 1 actually will be nice. So if I put in negative 1, 2 times negative 1 is negative 2, plus 3 is 1. The square root of 1 is 1. So again, I'm just plugging in underneath the radical to see what I get. So 2 times negative 1 plus 3 is 1, and the square root of 1 is something nice. So at negative 1, square root of 1 was 1. Okay. Now let's see what else I can put in there. I think if I put in a 3, okay, so I'm going to go 2 times 3 plus 3, and I end up getting a 9, and the square root of 9 is 3, so I'm going to go to 3, because I put in a 3, and I am going to get out a 3, 1, 2, 3, because the square root of 9 is 3. So again, I'm just plugging values in here, and I'm trying to get nice perfect squares, okay? So I put in negative 1, and when I put in a negative 1, I get negative 2 plus 3 is 1. Square root of 1 is 1. I put in a 3. 2 times 3 is 6. 6 plus 3 is 9. The square root of 9 is 3. Okay? And now let me connect these points. And when I have this graph, you see that it does cross at 3, comma 3, but what I care about is the x-coordinate. So this 3. So my answer is going to be x equal 3. X, let me make it a little thicker. X equal 3. And that's the answer that I got above. Now, if I was dealing with this negative of this, it would have come down this way, and that's when I would have gotten this negative 1 here. Okay, but you see we're only dealing with the principal root, so this is the only answer. Okay, so let's look at the next problem. So the next problem on 30, they're giving us this 12 over x is equal to negative quantity x minus 3 squared plus 4. We're going to think of this, instead of solving this algebraically, we're going to think of this as a graph. We're going to graph y equal, so we're going to graph y equal 12 over x, and then we're also going to graph y equal negative x minus 3 squared plus 4. Okay, we're going to graph it on the other side of this. I have graph paper on the other side. And we're going to do the same over here on this problem. So here we have a cubic and a quadratic. So we're going to have y equal 1/2 x minus 2 cubed plus 1. That's one graph we're going to graph. And the other one's going to be 2x squared minus 6x minus 3. Okay? And we're going to be putting this into Desmos and graphing these. Okay, so for this one, let's actually graph this one just by hand. I think we can graph this one. So remember, when we have something like this, you want to think x, y equal 12. What multiplies to 12? So 1 times 12, so 1 comma 12. Okay, so 1 comma 12. 2 times 6, so 1, 2, 3, 4, 5, 6. 3 times 4, 1, 2, 3, 1, 2, 3, 4. 4 times 3. 5's not going to be nice. 6 isn't going to be nice. Sorry, 6 is going to be nice. Sorry. 6 and 12. So 5, 6, and 2. And then I can go out to 12 and 1. Let me get a thinner one. Okay, now I also have the other branch of this. So this was all positive times positive. So again, I'm still trying to multiply and get it 12. So I can take a negative 1 times a negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And negative 2 times negative 6. 1, 2, 3, 4, 5, 6. Negative 3 times negative 1, 2, 3, 4. Negative 4 times negative 3. Negative 5 is not nice. Negative 6 is negative 2. And then negative 12 would be negative 1. Okay. And let me connect that. Okay, so there is my y equal 12 over x. Then I'm going to be graphing this parabola, and it has a vertex at 3 comma 4. And it's negative, so it's going to be going down. So I'm going to go to 3 comma 4. So let me zoom in. Okay, 3 comma 4, 1, 2, 3, 1, 2, 3, 4. So they share that point. And then this is a regular parabola, so except for it's going down. So if I go over 1, 1 squared is 1, times it by a negative, negative 1. So I got another point. Same on the other side. If I go out to 1, 2, 2 squared is 4. So it's going to be a negative 4, 1, 2, 3, 4, and same on the other side. If I go out 3, 1, 2, 3, 3 squared is 9, so it's going to be a negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same on the other side. And let me go out 4. 1, 2, 3, 4. That's going to be a 16, so I'm going to go down negative 16. Okay, so that was 4, 5, 6, 7, 8, 9. Okay, so that was 9, 10, 11, 12, 13, 14, 15, 16. And it's going to be same on the other side. Now, as you see, when I go to the other side, sorry, okay, there's my 16. When I go and do it on the other side, it ends up here. So I actually am going to have this cross in 3 different places, okay? So let me just connect it. So here's my parabola. Here it crosses once, twice. Oops. Do it again. Okay. So it crosses once, twice, and 3 times. Okay, so I have it cross 3 times. So the 3 places that it crosses here. It crosses, let me make it a little brighter. Crosses here, it crosses here, it crosses here. These are the 3 places that it crosses. So if this was a system, we would actually need the points, okay? So this would be 1, 2, 3, 1, 2, 3, 4. So 1 would be 3 comma 4. Let me get a different color here. Okay, so this one here would be 3 comma 4. This one here would be 1, 2, 3, 4 comma 3. And over here, for this one, it is -1 comma -12. Now, those would be our answers if this was a system. If I was solving this system, y equal 12 over x, and y equal negative quantity x minus 3 squared plus 4. But we're not solving it as a system. The original problem was this. So our answers are going to be x equal -1. We just need the x's. There's no y in this equation. So we only need the x coordinates. X equal -1, x equal 3, and x equal 4. So those would be our solutions. Okay, let me get. Okay, so x equal -1, x equal 3, x equal 4. So we're using this system to solve, but again, the original problem did not have a y, so we do not need the y coordinates, we just need the x coordinates. So we're going to do the same thing with the next problem, but this one, let's use the graphing calculator, in this case Desmos this time. Okay, so let me get that going. So sorry, my document camera stopped there for a second, so let me reshare this. Okay, so we are really solving this. 1/2 times the quantity x minus 2 cubed plus 1 equal 2x squared minus 6x minus 3. That's the original problem. We're going to think of it as a system. We're going to graph the left-hand side, which is a cubic. We're going to graph the right-hand side, which is a quadratic. I'm going to put it into Desmos. Okay, so I'm going to type in y equal 1 1 divided by 2 times the quantity x minus 2 squared, sorry, cubed. Let me go back. Cubed plus 1. Okay. And then I'm going to graph y equal 2x squared minus 6x minus 3, which is a parabola. Okay. And so we see that it crosses here at 0, -3. We see it crosses here at 4, 5. I know for sure that it is not crossing anywhere beyond this 0, -3, because this is going up forever and this is going down forever. But let's check as we go here. So as we go here, it's kind of hard to see. So what I'm going to do is, instead of zooming in and out, which is going to keep this going by the same scale as this, I think I want my x's smaller, and I think I want my y's bigger. So I'm going to go to the wrench. I'm going to put it on projector mode so it's a little bigger too. And I'm going to come here, and let's say for this, -5 to, let's say, 15. Let's kind of see how that is. And for this, let's say -10 to, I don't know, I'm going to say 100 because I'm not really sure where it's at. Okay, so now when I see it, I see that it crosses here at 0, -3. I see it crosses here at 4, 5, and I see it crosses here at 633. Okay, so those are going to be the points of intersection for the system. But again, this wasn't a system, so I do not need the y coordinates. There was no y in my original problem. I just need x equals 0, x equal 4, and x equal 6. Okay, so let me go back to my. So I came back here. I'm just going to do a sketch. I put down the coordinates 0, -3, 4, 5, 6, 33. Okay, and I know that one of them is a cubic, and the other one is a parabola. And again, I'm just sketching them. Okay, not making this perfect by any means. Okay, so I know it comes through this point, comes through this point, and it goes like this. And so in this case, again, these would be the answers to the system, but it's not a system. I need just the x's. So the solution to the original problem is going to be x equals 0, x equal 4, and x equal 6. And that's the end of this video.